Hello Flame community, this is Jeff Kyle with the Flame Learning Channel. Compensating for lens distortion is a relatively standard practice in compositing, and with the release of Flame 2025, workflows for handling lens distortion have been significantly expanded, introducing a number of new enhancements to make you faster and more efficient, all without leaving batch. In this first video, I'll be going over the basics of lens distortion, and then jumping into the various inputs, modes, models, and controls within the node, and end with a simple example of how to use the lens distortion node in your next composite. In general, when working with footage shot on a camera, there's some level of distortion that is often evidenced by looking at the straight lines in the footage. Lens distortion workflows seek to analyze the image or analyze a lens distortion grid and then compensate for the distortion to allow you to undistort the image, work on your composite without the distortion getting in the way, and then re-distort the work you've done to match the original footage. When it comes to simple compositing work, this workflow might be a little overboard depending on what you're doing, but the more complex your composite might be, such as CG integration or using 3D camera tracking workflows, the greater the need to compensate for lens distortion. Here we are in batch, but before we jump in, it's worth mentioning that with Flame 2025, legacy nodes are now hidden by default, and the legacy lens distort node falls into that category. You can always click on this gear icon right down here and select Show Legacy Nodes, after which you'll be able to see both the new lens distortion node as well as the legacy lens distort node. But for now, let's take a look at the brand new lens distortion node. I'll pull it out from the bin and we can see right away that there are three inputs. The first is front, where we connect our footage to be undistorted. The second is a lens grid input, where we would connect our lens grid if we're provided with one. As is standard practice, we should ensure that we are using the lens grid that is associated with the same camera and lens associated with the footage that we're working on. And the final input is the matte input, but this is a special matte input that isn't used for compositing, but rather is used to apply the same lens distortion we're applying to our front to our matte. Looking at the controls, starting from the left, we have our distortion mode. By default, we start out in undistort mode, but this button will allow us to toggle between undistort and distort mode. Beneath that is where we choose the lens distortion model, and opening up the dropdown for this section, we see that there are a number of models available based on the industry standard 3D equalizer distortion toolkit. Next is the detection controls, which are grayed out because right now I'm looking at the result, or F4 view of the lens distortion node. These controls become active once we've switched to the front F1 view or the lens grid F2 view. Before we go too much further with the controls, let's go over a quick one-click workflow for undistorting our footage. I'll delete the lens distortion node and start fresh. Notice that when I connect the front input to my footage, since I'm not looking at the front view in my viewport, pretty much everything is grayed out. But when I connect the lens grid to the lens grid input, the calculate button becomes available. There are a number of controls for dealing with detecting lines in the image and setting up splines to help with the distortion calculations, but when Flame detects that you have a lens grid, we have the option of relying on the default settings to quickly calculate the lens distortion for that image. I'll switch to the result F4 view, click Calculate here, wait just a second for it to calculate, and Flame has successfully removed the distortion from the image based on the lens grid. Continuing along with the interface controls, we'll leave the middle section for our next video where we dive into the advanced features, but over on the right side we have some familiar controls for repeat mode, output resolution, and filtering. Repeat mode is what you might remember seeing from the 2D transform node or various maps inside of Action, and it allows us to control what happens at the edge of the frame, whether we see black with repeat off, repeat the last pixel, tile repeat the image, or mirror repeat the image. Moving over to the filter section, and if we are familiar with filtering inside of Action, we might notice that the default is not a familiar selection. We have two new filtering modes available to us here, whereby the default is set to the Mitchell-Netravelli mode, and the other new mode is Catmull-Rom. But we can switch this to our filtering mode of choice based on our preference and the needs of the image. And finally, we have the output resolution section with some more familiar controls. By default, it's set to auto-scale to scale the image based on how much distortion has been removed to ensure that no cropping will take place on the image and the resolution of the image is expanded to compensate. If we switch the output resolution to user-defined, we can manually set this value. And finally, we can choose to leave the resolution the same as front, which could potentially result in some cropping once we've distorted the image. But for now, I'll switch it back to auto scale. Moving on to outputs, the Lens Distortion node has 4 outputs, and I'm going to toggle through all of them with the F4 keyboard shortcut. The first is Result, which displays either the undistorted image, as is the case with me, since that's what I have hooked up and that's what my settings are set to, or the Re-Distorted image if your settings are set to distort. The second output is an ST map with the undistort data, and it's labeled as ST map. The third output is another ST map with the Re-Distort data, labeled as inverse ST map. And the final output is the matte output with the distortion mode applied. Now that we've covered the interface and the basics, let's finish this up with the Re-Distort workflow. If you remember back earlier in the video, we did a one-click undistort using an automatic detection from the Lens Distortion grid. Now it's time to re-distort. There are 2 pathways ahead of us. One is to use the inverse STMap output of the Lens Distortion node with the new STMap node. If we know that the same camera and lens is used on multiple shots, we can use a render node or write node to output the STMap and inverse STMap from the Lens Distortion node, and then use the STMap node to use this data on multiple shots without having to spend time calculating with the Lens Distortion node. The other pathway, and the one we're going to use in this case, is to duplicate the Lens Distortion node and connect it to the result of the first Lens Distortion node. The last step here is to, on the second Lens Distortion node, switch the mode from undistort to distort, but pay special attention to the output resolution field because there's some magic that's about to happen. When I toggle the mode to distort, the output resolution automatically changes to user-defined and also automatically sets itself to the resolution of the front clip of the first Lens Distortion node. Very cool automation and very quick to use. In the next video, we'll be going over some of the more advanced features of the node, but for now, if you like these videos and you're finding them helpful, please subscribe to the Flame Learning channel and click the bell to stay notified about new content. Feel free to comment any questions or suggestions below. Until next time, thanks a bunch for watching.